Welcome to the Kaiweets HT200B mini clamp meter review. I'm Suey778 coming at you, and let's go ahead and take a look at this. Let's do a quick unboxing of this. Well, let's take a look at the box first. Kind of a pretty box. Picture of it on the front with the model number on the back, some safety statements, and that's about it. So let's go ahead and open this puppy up. I've already opened this, but we're just going to do it again, just to show you what you get when you open it up for the first time. You get a manual. We'll talk about this manual a little bit later. You get a pair of leads. And of course you get the meter. And there you have it. The Kaiweets HT200B. Get some of the stuff out of the way here. Alright. Okay, so let's take a look at the leads real quick. As you can see, they come with guards, and of course they're tangled up. That figures. These are PVC leads, so yeah, they tangle up really easily. You will notice one thing about these leads here is you can see they're the standard size, but they're not the standard length. These are actually a little bit shorter. Let me take the covers out of this. And then you get the guards. Now, where's the black one? There we go. Okay. Those are on there pretty good. Alright, so here are your probes, standard size probes, the shiny, cheap, plasticky stuff. Not a whole lot of play down here. There's some. They're okay. And then you got the leads. There is one thing I did want to show you though. Let me get a standard size lead here and compare these two. The standard size lead here is on top, and this is on the bottom. As you can see, these are a little bit shorter. Not much, but a little bit. Okay, so general overview. Let's get this stuff out of the way. Get this box out of the way. Alright. The clamp itself is, or the meter I should say. The meter itself is pretty small. I got small hands, and I mean this thing even looks small in my hands. It's not very big. It's got a nice grippy clamp. It has a rotary dial, which I'm not particularly fond of. Works best when you operate it with your thumb. If you're trying to do it this way, don't bother. It's a pain. The general features of this, the modes of operation that we have are the you get your clamp current readings up here, the 200 amp range, 20 amp range, 2 amp range. You get your AC voltage readings here, you know, like when you're checking sockets and stuff like that. Down here you get your DC voltage, and here you get your continuity, resistance, diodes, and then finally capacitance. You get a function button that's only going to work on this setting right here, since it's basically that's the only one that has more than one choice. You got a maximum button and a hold button. The hold is just a freeze frame, and you also get a backlight. Unfortunately, the backlight does not stay lit up. I think it stays lit for about 20 seconds, maybe 25 seconds, something like that. Anyway, this is a 2000 count meter, so not real high in count resolution, but it does the job. About the build quality, it's pretty good. Feels almost like polymer plastic. I don't know. It's probably just regular hard plastic, but I mean it feels pretty well built. You know, there's no rattling or anything like that, so that's good. Now this is a category 3 600 volt reading. I don't think so. I would say more like category 2 for households or hobbyists, but say for current readings on AC because of the clamp. which is how I would recommend doing it if at all possible, or use a kilowatt. You plug it into the wall. You don't have to mess with probes or anything like that. That's how I do it. Anyway, let's look at the batteries that this thing uses. So you got a little, oh, and this does not have a stand, unfortunately. Unscrew this real quick. All right. Did I get it out? Nope. Kind of a long screw on this. There we go. Okay. Comes right out. It's not a captured screw. It comes with a pair of PK cells, which I obviously put back in. You will get these in a box. And these are not PL cells. I've heard so many people on these reviews call them PL cells. They're not. That's just a funky looking K. It's actually PK cells, and these are actually pretty decent batteries. They are Chinese. I have a number of 18650 cells from this company, and they're actually pretty good. So basically works on a pair of AAA batteries, which, you know, which is just fine. This thing can't imagine it'll pull a lot of power. Let me go ahead and put this back on, and it's very easy to get this back on. You just shove in the tabs down there at the bottom and then screw this puppy back in. The long screw. And I forgot to mention the screw here does have a nice, you know, it's brass instead of the plastic, so you're not, every time you take this apart or put it back together again, you're not dropping shards of plastic down inside the unit. I'm not going to do a takedown of this. We're just going to get right to the test here. So give me 1 second. I'll get set up and we'll be right back. All right. One thing I did forget was the manual, and basically it's a pretty well written manual, and it's actually you know, in a big enough font that old farts like me can actually read it. See, the specs here are towards the back. The specs aren't bad. Like I said, you know, you can take a look at that if you want. This is not the most ideally shaped. And then here's your accuracy. Not too bad. I would say that the weakest link on this is probably actually the diode measurement, but we'll get into that. The rest of it is relatively accurate. So anyway, there you go. There you have the manual. Now we're going to get to some tests. Okay, and before we get started here with these measurements, let me just say for a couple of these tests, including the DC voltage test, which I'm doing first, I'm going to be using a set of banana plugs just because it's more convenient for me to operate my bench power supply that way, and I just think it's a more stable way of measuring it. We're also going to do that with the resistance box. Otherwise, the rest of the test we will be using the probes. So let me go ahead and get my banana plugs plugged in here. Hopefully this fits. I never actually tried this. Yeah, they go in. Cool. Alright. So we're going to put it down to voltage here. DC voltage. See what I mean about, yeah, always use your thumb. Okay. And I'm going to zoom in on this a little bit so we can get a good look at these readings. Just a little bit. There we go. There's your backlight, by the way. Okay. Alright, so we're going to start it off with 2.5 volts. For those of you curious of what I'm using a Rockseed RS310P programmable power supply, 32 volts, 10 amps max. And here we go. I'm going to turn it on and see what we get. Okay, this is 2.5 volts. It's reading it dead on. That's nice. Alright, let's move it up to 5 volts. And we get 4.90, 5.0, right on the money. Not bad. Alright, let's go to 7.5. And that's me twisting my nose. What I like about this power supply is I can actually specify exact numbers. Okay, here's 7.5. We're getting 7.51, so again, pretty close. All right, cool. All right, let's go up to 10. And we're getting 10.01. Again, very good. 10.02. Works for me. All right, we'll run this up to, well, let's do 20 volts. Actually, let's just put it all the way up to 32 volts. Let's see what it does. There's 32. And it is reading it as 32. Not very good resolution, but it is reading these voltages quite accurately, so that works. Okay, so we're going to test the AC voltage and the AC current here on this meter. We're going to do it first with an AC test. As you see, I got my little kilowatt plugged in, and it is reporting 121.2 volts. And I'm just going to take the probes here and stick them in to an outlet. I don't personally recommend doing it this way. This kilowatt's a much safer way of measuring outlet voltage, in my opinion. But we'll do it anyway, just for the sake of testing it. And we are getting 121.4. Okay, I actually need to get these probes in a little bit better. But yeah, right around 121.5, 121.4. Did light up orange, so that's good. So that does work. Unfortunately, you can't measure hertz on this. It's a little bit inaccurate because this kilowatt generally has been very accurate for me, but that's close enough. Okay, let's go ahead and do move over to the clamp test. Put these aside here. Alright, let me turn this off real quick, and we're going to get this kilowatt out of here. Alright. Then what I've got is a line splitter. This is a Klein Tools line splitter. Let me put that in the camera here. And as you can see, it's a 15 amp, but it's a 10x multiplier, which basically means whenever I put this in here, it's going to give the readings at 10 times the amount to the multimeter. Alright, so let's go ahead and put this in. I figured this would be a really good way to simulate the high voltage in this, since I really don't have like any, high power pumps or anything like that I can use. So let's go ahead and plug this in. Actually, let's push this up a little bit because I'm going to need this to come in there. And let me go ahead and put let's put it into clamp mode. I'm going to put it into 20 amps just to be on the safe side. Okay. Alright, it's measuring nothing at the moment. Okay, and we got a space heater here. And I'm going to put it in fan mode first. Let's get the power turned back on here. So here's the fan mode. And it does pull. It's actually pulling about 2.03 amps. That will actually settle down a little bit. Not going to be able to put it in a lower reading though, not with that reading. Let me make sure this is, yeah. Okay, it dropped down to 199. Let's see if we can get it in the 2 amp range. Let's see how accurate that is. Yeah, it's complaining about it. Alright, well anyway, at least we know that works. Okay, that's reading 1.96. Well actually that's 19.6 milliamps. Okay, so let's go ahead and put this on low heat, and that put it over limit, so we need to put that up to 200 amps because remember we got this multiplied. And what we're getting here is about what this space heater does pull on low power, which is 6.4 amps. It's reporting it as 64 amps. Let's go ahead and jump up to high. 122.5. So Seems to work as advertised, and it seems to be pretty accurate. And yeah, this space heater pulls about 12.25 amps on high power. So I would say we're good to go there. Okay, next up we're going to measure some resistances with this resistance substitution box. Just keep in mind that these type of substitution boxes do add a little bit of resistance into the circuit without any switches engaged, generally about 1/4 of an ohm, maybe 1/3 of an ohm. This particular one does about 1/4 of an ohm. So let's go ahead and get this plugged in, and let's see what we get here. And you will see this reading come up as soon as I plug this in. And as you can see there, yep, it's actually with the banana plugs, and this is why I prefer doing it. It actually shows it a little bit. It actually removes a little bit of that resistance. So I'm probably getting about 0.14 there, so we'll just keep it at that. All right, so let's try 1 ohm here. And I'm getting 1 ohm exactly. Okay, that'll work. All right, let's go up to 10 ohms. 10.2, and there's that added resistance that I was talking about. This will happen up to about the range of 400. So let's go ahead and try 100 ohms. And yeah, we're getting about 100.3. That's probably really more like about 100.1. Alright, let's go to 400. That's right on the money there. So yeah, this is about where, you know, that added resistance doesn't matter anymore. Let's go to 1K. And we've got right on the money there with 1 kilo ohm. Oh, dropped 1 digit. I'll take that. Alright, let's go to 10K. A little high, but close enough for me. That works. Alright, let's try 100K. Had to think about it a little bit. 100.3K. Alright, that's cool. Let's go for the big meg. And we've got 1.009. Alright. Let's go to 2. 1.997. Not bad. We're going to lose resolution here when we go to 3. Yep. 2.99. Pretty close. And 4 meg. And this unit will go up to 20 meg, by the way, I believe. We got 3.98. Alright, let's go up to 10 meg. 9.98, not bad. And since we can do it, let's do a Nigel Tufnell. Let's go to 11. And we get 10.95, 10.97. Still thinking about it. It looks like it's settling at 10.98. So for the resistance, not bad. Okay, next up we're going to do continuity, some diodes, and some capacitance checks on this. On my little prototype tester board for multimeters. It's still a work in progress, but we're getting there. Let me get this off. I just want to make sure we get some good readings here. I'm going to zoom in a little bit so we can actually see it. We're going to use the Kaiweets own probes for this, so let's get these plugged in. As you can see, these fit perfectly. Going to do this side by side just because that's just the easiest way to do it. You know what, I forgot to do the min and max, but the max does work. It does not do minimum actually, it's just maximum for this. I forgot about that. And the hold, like I said, it's just a freeze frame, so we're not going to bother with that. Anyway, so let's go to continuity. I believe that's continuity. Yeah. There we go. Alright, so we're going to test the leads for continuity here. Pretty good latch. Pretty fast reacting. Of course, you see the little light there indicating. The light's a little bit slow. Pretty fast. That's not really a good way to check continuity, by the way. The correct way is to do it like this. Got it? Alright, now that we got that out of the way, let's do some tests. First we're going to do some diodes. So let me put this in diodes mode. Okay. Alright. Let me get my little chart out here for this because I'm going to need that. The ones that I have on this circuit board I actually have tested, so I have a pretty good idea of what, where they're going to read. This first one is going from bottom to top. This is an IN 4001 rectifier. This usually fires in at about 0.556 volts. And we're getting 530, it looks like, 530 millivolts. And the other cool thing about this, this meter does report continuity when measuring diodes, so that's nice. Next up here is a FR207 fast recovery. This particular one averages about 518, getting 497 on that, so about 20 counts low. The next one is a Schottky. This one usually weighs in at about 204. And we're getting 190. Alright. Next one is a switching diode. This one usually comes in at about 615. We're getting 589. And the last one is a germanium diode, which usually comes in at about 285. And we're getting 269, so not too badly off on that. It seems that these do have this meter has a tendency to measure diodes a little bit low, but not to the point where it's horrible. But it would have been a little bit nicer, it would have been a little bit more exact. But anyway, let's go on to the diode test. First we're going to do a red. Okay, lights it, and we're getting a reading. Yellow, lights it kind of, but we get a reading. Alright, let's go to the green. Lights it, but no reading. You can tell I haven't soldered these in yet. The blue, nothing. Okay, and the white, nothing. Alright, so let's check the output voltage on the HT200B. And it looks like we're getting 2.257 volts. That explains why it's not lighting up the blue and the white. Okay, so that's fair. I mean, you can test some LEDs with it, just not all of them. Alright, not going to do resistors since we already did that. This is, like I said, this board's incomplete. We're going to do a couple of caps here. So let's go to capacitance, actually. I think that's in capacitance. Yeah, okay. So this first one is a 10 microfarad cap. Should get, this one averages around, let me see, this one averages about 10.53, so this one's not exactly on spec. It's a cheap capacitor. We're getting 10.59, so a little bit high, but yeah, not bad. Not bad. Let me move this up a little bit so my hands don't get in the way here. Alright, this next one up is a 100 microfarad. This one averages about 101.3. If I get it to hold still. There we go. 103.0. That's still, okay, it's settling around 102.9. Alright, not too far off. I'll take that. And up top here I got a 2200 microfarad. I don't think this is going to work with this meter though, because the top end of this is 2000 microfarad, but we'll try it anyway. It's trying. Yeah, over limit. Okay, so there you have it. Those are your measurements. I think we've covered everything in this section. Yes, we have. All right, let's move on. I'm going to give you my conclusions here. Okay, so that brings me to the pros and the cons of this review. For the pros, it's got good accuracy on voltage, current, resistance, and capacitance readings. Very nice and very well done, Kaiweets. I like that a lot. And it's fast on continuity testing, very reactive, but has a good latch lock, so again, that's very cool. Nice clean display with a pretty good backlight. You do get a little bit of a burn-in, a little bit of a hot spot on the left-hand side, but not a big deal. It looks great. It's great dual color display, so when you get into high current it turns orange, so that's nice. Solid feeling clamps that are easy to fit in tight spaces. That is an advantage about having a small meter like this. And of course the overall unit itself is compact. So you could stick this thing in your shirt pocket, and I did. I tried it, and it works, and it sits there just fine. Bang for the buck. The accuracy alone on those readings makes this worth the $19 that I paid for it, and I would have gladly paid $22 for it. It has just enough features and does just enough things. It's a little bit of a specialty meter, but you know, it is what it is. And you know, for what you're paying for, you get a great value. And the manual is quite well written and in a font that I can actually read. You know, I mean, I'm in my early 50s, so my eyes aren't the best anymore. So I appreciate the fact that Kaiweets makes legible manuals. So very good. In the middle are these leads. Not really a pro and a con, just something I'm kind of you know. They're not very, you know, made out of cheap plastic. You know, the cables are plasticky. They get tangled easily. I mean, they're your typical low-end leads, but they seem to work well. And as long as you keep them clean, you know, they should be fine. And yes, I tested with these probes just simply because somebody that's going to buy this more than likely is not going to be looking to get a set of probe masters. You know, they're just going to say, all right, I got leads, let's go do some testing. That's really kind of how I looked at it. Not sure about this. If I can zoom in, it looks like this this red lead is actually already showing some signs of wear, which I don't like. If you can see that right there where my finger is. See if I can zoom in a little bit more. See what I mean? It's kind of, looks like it's already stressing right there, so we'll have to keep an eye on that. But if the leads crap out, then I'll buy the better leads for it. That's not really a big deal. For the cons, first thing is backlight does not stay on. That's kind of a bummer because it's got a nice backlight to it, but it does not stay on. Low count resolution. Again, it's a cheap meter. I mean, you can't have it all, but it would have been nice if it had say 4,000. And again, tends to have low readings on diodes. This is not a deal breaker for this, but just be aware that if you're using this, now it might work a little bit better with better probes, but I actually tried it and I didn't get any difference. I do have some better probes. But it's not to the point that it's unusable, but generally speaking on the diode readings, they tend to come in at about, you know, 0.2 on the low side. But still well within the ballpark to give you an idea of what kind of diode you're playing with and whether it's good or not. So not a huge deal, but just had to mention it. I don't like the probe connectors here on the bottom. I just don't care for it. There's enough room up here to fit these things, and you know, without doing all this big font stuff, I think that's kind of, you know, I would have preferred them to be up here. But it's small. It's not, you know, I paid $19 for it, so I can't complain too much. Lastly, the rotary selector is a bit fiddly, and again, I just don't care for the selector that much. It just doesn't work. It doesn't get stuck between, you know, settings, which is good, but you know, that could have been done better. I mean, it's real small, but it could have been, I guess they really couldn't make it any bigger. I don't know. Anyway, I would say that that leaves something to be desired. But again, $19 meter works fine. It doesn't feel like it's going to fall apart or anything. So it seems solidly built. So that's fine. Okay, and that brings me to the conclusion. And my conclusion on the Kaiweets HT200A is that it is a useful, low-cost clamp meter with respectable accuracy and good build quality. This meter would be great for anybody who needs a clamp meter that doesn't have to measure very high current. It's also useful, or would be useful, as a household tool for the average user. So I definitely would recommend it, especially for the amount of money and the accuracy in most of the readings. That's awesome. So Kaiweets HT200B, I give it my thumbs up. It's a good little meter for not a whole lot of money. Anyway, thanks for watching this review. I'm Suey778, and we'll catch you the next time.